Today's daily is looking pretty fun, actually. I've just been reading it and coming up with an initial strategy, and we'll see how that goes. So we have 3016, minimum number of pushes to type word 2. You're given a string word containing lowercase English letters. Telephone keypads have keys mapped with distinct collections of lowercase English letters, which can be used to form words by pushing them. For example, the key 2 is mapped with A, B, C. We need to push the key 1 time to type A, 2 times to type B, and 3 times to type C. It is allowed to remap the keys numbered 2 to 9 to distinct collections of letters. The keys can be remapped to any amount of letters, but each letter must be mapped to exactly one key. You need to find the minimum number of times the keys will be pushed to type the string word. Return the minimum number of pushes needed to type word after remapping the keys. An example mapping of letters to keys on a telephone keypad is given below. Note that 1, asterisk, pound sign, and 0 do not map to any letters. So, I feel like this problem is just a matter of boiling down a very wordy sounding scenario into what I believe is actually a pretty simple one. So, for example, it's saying that for a word, you could theoretically remap the letters to make it so that you only had to push, whereas usually if you pressed A, B, C, D, E on a default one, you'd have to press A once, then B twice, then C 3 times, and that's like already 6 pushes just for 3 of the letters. When if you map it differently, you can have all of those letters be the first letter, and then you could have 5. Because, yeah, you only have to press each button once. So, I feel like at first this problem seemed a little intimidating, but I feel like it's pretty straightforward if we just boil it down to a few key principles. So, the goal should be to maximize our number of 1 key presses and then 2 key presses and so on. And the way we would do that is by assuming that the letters with the highest frequencies are the letters that are assigned to the first character. So what we want to do, well, and then we would just sum up the cost from there. So we would take the word, and count the appearances of every letter. We would then sort those appearances by frequencies. Then, actually, I'm going to type this out. This will be good. So we're going to count appearances of every letter. We're going to sort letters by appearances, by frequencies. Okay? The first through the 8th most common letters get assigned a first key press. Cost of 1 is really what we're thinking of here. Okay? 9th through 16th get 2. 2. 17th through 24 get 3. And then 25 and 26 get 4. Because keep in mind, there's only lowercase letters in Word, which, thank you. That makes it a lot easier on us. Actually, it doesn't really, because to be honest, like, with the way this is starting to look up, yeah, we're fine. Okay. But, so, I think that makes sense. Basically, if you end up using all 26 letters in the alphabet, that means that 2 of those letters are going to have to be in groups of 4. You're never actually going to need a group of 5. If there's 26 letters, because there's 8 possible keys you can press. I think this is just to confuse you. because there's 8 possible keys you can press. And so worst case scenario, so probably you're going to have 6 keys that have 3 letters and then 2 keys that have 4 letters. And those 4-letter ones, you'd only press those for the second 2 least used ones because you want to minimize the number of 4-letter presses that you have. Okay, so I think I'm talking in circles now. Let's do this. So first, let's count the frequency. And let's count the appearances. We'll call it frequencies. Okay. For character in word, I'm going to say if character in frequencies, then frequencies character plus 1. So if it's already in the map, then increase its frequency by 1. Otherwise, set it to 1 for a starting point. Okay, so now we have a dictionary that contains the frequency, that contains all the letters and their associated frequencies. So now I am going to use something because I was curious how I could sort a dictionary by the values, and I found a good way of going about that. So I'm going to type it in now. We're going to say sorted frequencies equals sorted, because we can use the built-in Python sorted, frequencies dot items. I'm going to type this in and I'll explain it. Key equals lambda x 1. Okay. So, here's what this line means. Frequencies.items will return tuples for all of the entries into the dictionary. So tuples being the key and the value in one pair. All right, so like mini arrays, just two value pairs. Okay, so it's going to sort those. But how is it going to sort those? It's going to sort it with this key right here. And this key uses this anonymous lambda function. We're saying, okay, so for each pair x, we want to sort it by getting the second value, by getting index 1 in the tuple, because we want to sort it decreasing by frequency, because we want the highest frequencies first so that we can give them a cost of 1, and then once we get through the first 8, we start giving costs of 2, and so on. So we want the highest frequencies first, because if we don't want the lowest frequencies first, because if we have the lowest frequencies first, we don't know if we want to start with 4 or 3 or 2 or even 1. So it makes the most sense to start with the highest frequencies. And the way we do that is by getting the value, and then here's the cute part, is we make them all negative. So we're getting the negative values so that the, oh wait, what was it? Oh yeah, because this way it's counting up. So the problem is that it would be starting with the lowest frequency. So by making them negative, the highest frequencies now become the biggest negatives, and therefore it starts with those. It's kind of cute. I think it's a very elegant solution. But yeah, so instead of like, if you have 1, 2, 3, 4, but you actually want to start with, you want to count the other way, you say, okay, make them negative and then return that. Now you have -4, -3, -2, -1. That's pretty cute. Okay. Now, the first through 8 get the first key press. being the cost of 1, and then so on. So we're going to have a counter. That counter is going to count upwards in 8. All right. And yeah, so this seems like a good job for modulo, because modulo will tell us when we hit values of 8. So now we're going to say letter costs. Okay, so this is going to retain, it's going to be similar to frequencies. It's going to contain all the letters we found in the word, and it's going to match them with the pair of how much it costs to press that letter. So if you have to press the key twice, it costs you 2. So letter cost equals that, and now we're going to start with an initial cost of 1, because you have to press the key at least once. So the cost equals 1. Okay, so for, let's see, we're going to say for, how do we use like an abbreviate? Yeah, for SF in sorted frequencies. Okay. We're going to say letter costs it will be SF0, because the sorted frequencies are now tuples. And so we want to get the first part, which is the key of that tuple. So this is the letter, and then we're assigning a new entry into that dictionary. We're going to say that has a cost of cost. Okay? Let's see. Now we can say, maybe we should just have a counter for this, so maybe just have it be an index-based for loop. But how about we can say if length of letter costs modulo 8 equals 0, then costs plus equals 1. Okay, so once we get to 8, now the next entry will be the 9th entry, which means that the 9th entry is going to need a cost of 2, so we up the cost by 1. And then when we get to 16, we do the same, and then when we get to 24, we do the same. Okay, awesome. So now we have the costs of all the letters. Now we just need to combine the frequencies by the costs. So now we can just say for LC in letter costs, we're going to multiply how often that letter appears by how much that letter costs. So if A is the first key, it only costs 1 to press it, and if it appears 5 times, then we do 5 times 1 is 5, just like that. Except that's A, B, C, D, E, but you know, same thing. Okay, so we're going to say, let's see, for LC and letter costs. I guess we could, how about we do SF, because those are like cute little tuples. I feel like it's, I don't know. No. For LC and letter cost dot keys. Okay, because we just need the keys. I mean, to iterate through it at least. Okay, we're going to say, now we're going to have total cost, and total cost starts at 0. We're going to say total cost plus equals LC no. Yeah, letter costs LC times frequencies LC, because they'll have the same number of keys, because you know it's just one key for every letter appeared. Okay, that should do it. Let's see if that works. Hopefully it does. Awesome. Okay, let's hope that works for all of them. Cool. Okay, so little slow. I think that maybe I could have. Maybe it's just like the way I. Maybe it's because I used the length. I wonder if it would be faster if I had like letter count. We start that at 0. Because instead of accessing the length of the dictionary every time, although that shouldn't be that much slower. I'm going to say letter count plus equals 1. And now if letter count modulo 8 is 0. I'm thinking that might run just a hair faster. No, it ran slower. Interesting. I don't know. Regardless, that's a great puzzle. And yeah, I enjoyed it. I'm curious to see maybe people use okay, yeah, frequency counting, sort the frequencies, calculate the total presses. Okay, so it looks like everyone had the same solution as me, to be honest. Did I just like do... That's the exact same. Maybe it's because this guy starts out... Oh. That makes a lot of sense. So this guy makes a great point. You don't actually need a dictionary. An array will do because you know that there's going to be at most 26 characters, and you can tell, since the alphabet's also sorted, you can tell which letter is which index based on the yeah, just, you know, like A is the 0th index and so on. And that should run just a hair faster than a dictionary, I think. Could be wrong. Anyway, this works just a hair slower than most other solutions, but it gets the idea across, and everything's going to boil down to this essential logic. So that was a great daily puzzle. Thanks for watching, and see you on the next one.